Today, I'm going to talk about electronic configuration, the easier way. So how you fill up the orbitals in an easier way. So that is what it is called the electronic configuration. So if you see this, this is energy levels, first energy level, second energy level, third energy level, and fourth energy level. And on the bottom, there is nucleus. So these energy levels are going far away from the nucleus. And the first energy level, second energy level, third and fourth and fifth and go on. And those are called the principal energy level. Principal energy level. And those principal energy levels are also further subdivided into a sub-level. Those are called the energy sub-levels, or the orbitals. So first energy level, first principal energy level is subdivided into one sub-level that is called 1s. Second principal energy level is subdivided into two energy level that is called 2s, 2p. And third principal energy level is subdivided into three energy level that is called the 3s, 3p, and 3d. And fourth one is divided into the four sub-level that is called 4s, 4p, 4d, 4f. So when the electron comes, basically it gets filled up first with the 1s, this goes with 2s, 2p, and go on like this. So this is the lowest energy level, and the other is going up as the highest energy level. So the electronic configuration, basically the filled up from the lower energy level to the higher energy level. So, but there is some exception to these energy levels and energy sub-levels. So if you see on this one, on the diagram on the right, the one on the left I explained to you, and the diagram on the right, that is the energy sub-level. So there is some exceptions are here on the order of filling or order of energy sub-levels. So orbitals are filled in the numerical order. So it goes 1, 2, 3 like this. But there is the exception. Principal energy level get closer together as you get farther from the nucleus. So what does it mean? That means the principal energy level, as you go further and further from the nucleus, so the nucleus is on the center and at the bottom here. So the first, second, third, fourth, fifth, like that, the energy level goes further and further. So the difference between those energy level become smaller and smaller. So they come closer towards nucleus because of the attraction between the nuclear force as well as the energy level. They get minimized. That's the reason they get closer to closer and closer. And because of that, these energy level, if you see the difference between third and the fourth energy level, is lesser than the difference between the second and third. And if you compare this versus first and second energy level, that is the highest difference. So this is the bigger energy level difference. This is the smaller, and this is the smaller. So as you go further, so basically the energy level get closer and closer. And because of that, these exceptions happen. So if you look at this here, the 4s was here, but it get overlaps with the 3d. It comes before 3d because of this energy level changes. So the 4s comes before 3d. So this is the first exception. There are other exceptions in the higher energy level also, but this is what the first exception is. So the filling electron filling order basically goes 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 4d, 4f, like that. So because of the exception, this get exchanged with the energy level. So how you basically do easily the electronic configuration, how we fill up the electronic configuration easily. So there is a technique to it. So if you look at this diagram, so this is what the technique is. Basically, you need to fill up electrons in this order. So if you can draw this diagram, 1s, 2s, 3s, 4s, 5s, 6s, 7s, 8s, 2p, 3p, 4p, 5p, 6p, 7p, 3d, 4d, 5d, 6d, 4f, 5f. So this is what the order is. Put the arrows here, this is the order code. 1s first, then second 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4D, 5P, 6S, 4F, 5D, 6D, 7S, like that. So this is the order it goes like that. 1S, 2S, 2P, 3S, 3P, 4S, 3D, and move on. This is what the order it comes from this diagram. So now, if you can draw this diagram or you can memorize this diagram, so it's very much easy to fill up your electronic configuration. So we're going to try this two example, which is potassium and chlorine. So potassium, the atomic number is 19. That means you have to fill up 19 electrons. So how will you fill up in the electronic configuration? So you can use this diagram. So you can go 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, like that, until you get 19 electrons. So, but before you fill this up, just remember that 1s can hold up to 2 electrons, and p can hold up to 6 electrons. So s can hold maximum 2 electrons, p can hold maximum 6 electrons. Similarly, D can hold maximum 10 electrons. So based on this, we'll fill up this order. So 19 electrons are here. So we are going to fill up this 19 electrons. So let's see how we fill up these 19 electrons. So first 2 electrons goes with 1s2 here. Then the next goes to 2s2. Then next goes to 2p6 because p holds 6 electrons. Then next goes to 3s2 because the next s holds 2 electrons. Then it goes 3p6 because next is the 3p6. So because p holds 6 electrons. So right now 2, 2, 4, 6, 10, 12, 18. So I have 1 electron left. So 1 electron after p, basically the s is there. So it will go to the 4s. So this is the 4s1 because 1 electron is left. So all together 2, 2, 4, 6, 12, 18 plus 1, 19 electrons. So this is the electronic configuration of potassium: 1s2, 2s2, 2p6, 3s2, 3p6, and 4s1. So now let's try the similar way of chlorine. Chlorine has the 17. So from the periodic table, you can find this atomic number from the periodic table. So the 17 electron, we need to fill up this 17 electron in the order of electronic configuration. So this is how it will work with the 17 electrons. So again, it will go with this order. So 1s2, 2s2, 2p6, 3s2, and 3p5. So altogether, if you add up these electrons, this will be 17 electrons. So up to 3s2, you can fill up to 3s2. So after 3s2, you have 5 electrons left. So that will go to the p. P can hold maximum 6 electrons. So, but you have remaining 5 electrons. So only 5 electrons will go to the 3p5. So 1s2, 2s2, 2p6, 3s2, and 3p5 is your electronic configuration of chlorine. So apart from this regular electronic configuration, there is other way to do the electronic configuration. We can read the periodic table easily. So that is called the shorthand electronic configuration. So how that works is, so this is the this is my periodic table. So if you look at this, these are the groups, and these are the period. So the first group, second group, like that. So all these groups are here, and this is the noble gas. So electronic configuration, basically we consider the noble gas. So the one on the orange, that basically on the S block, it's called the S block because your outermost or the electrons are in the S block. And these are called the transition metal, the blue one, because it's basically the outermost electrons is basically end with P. And these are the P blocks elements. So P blocks, so outermost electrons basically end with a P. So, so how we can do this shorthand electronic configuration here? So let's see. So basically we have to consider the previous noble gas. So for example, chlorine, this is chlorine. The previous noble gas for the chlorine is neon. For potassium here, the previous noble gas is argon here. So we need to consider the previous noble gas. Let's see the potassium 19, how we do the shorthand electronic configuration. So for the 19, so 19 is in the S block. That means the last one end with S, the electronic configuration of the last, which one is the outermost orbital is S. So, but before that, the previous noble gas is argon. So we'll put argon because argon is 18, then one left. And after argon 18, one left. So one left, that goes to the 4s1. So this is the S1 block. This is the S2 block. All these are the S1 block, and this is the S2 block. Similarly, this is the P1, P2, P3, P4, P5 blocks. So this is how the electron configuration of 19 potassium works. So argon is the previous noble gas. After that, 4s1, because why this is 4? Because it starts with the fourth period. It starts with the fourth period. So this is 4s. If you start with the fifth period, this will go to the 5s. If you start with the sixth period, it will start with the 6s. But our potassium is basically starting with the 4. So this is the 4s. So argon 4s1. So similarly, 17 chlorine. So 17 chlorine is here. So the previous noble gas is neon. So neon basically 10. So out of 10, there are 7 electrons are left. So 7 electrons, the S got filled. Here the S2 is filled. So this is the third period. So 3s2 is filled. Then after that 3s2, then it comes at a 3p. So p1, p2, p3, p4, p5. It's end with the 3p5. So this is what the electronic configuration is. So the neon is filled, here neon. So after neon, the S is filled. So S is filled, basically 3s2 is filled, here 3s2, because this is S1, S2 is filled. Then P is filled, P1, P2, P3, P4, P5. So there are P5, this is P5. So that is how the electronic configuration works for the 17 chlorine.